Good morning, good afternoon, or good evening, wherever you may happen to be. It's a beautiful sunny day on Hackett's Cove, Nova Scotia, and welcome to the Nautel webinar series for the summer of 2018. I'm the host for today, Jeff Welton, Regional Sales Manager for the Central US. I do have a special guest with me today. We're talking about care and feeding at the AM transmitter site. We're going to talk a little about grounding, security maintenance, and anything else that happens to be of interest to me at the time. We'll trade some more stories. And our special guest for today is Michael Patton. Mike is with the firm of Michael Patton and Associates down in Baton Rouge, Louisiana. Mike, welcome.
Thank you. Thank you for having me.
Well, and Mike and I have known each other for probably 20 years. I think the first time we ran into each other was probably at a transmitter site back in my tech support days. And that site will probably figure fairly prominently in this discussion as sort of a witch hunt we had to go on in the course of troubleshooting some interesting challenges.
Yeah, that was 680 in Memphis. I'm going to see them again next month, actually.
There you go. All right, so what we're going to talk about over the next 45 minutes in that range is a little bit about grounding, protecting the equipment and the engineers. Equipment can be replaced pretty easily. Engineers are slowly becoming a graying breed, so we like to keep as many of our engineering friends alive out there as we can. And we're going to talk about how much grounding is too much, because you can have too much copper in the earth. We'll talk a little bit about keeping the copper and adding visibility to security to the facility. There's nothing scarier than a dark site at the end of a road and in meth lab country, unless it's a dark site at the end of a road in the some of the suburbs that we run into here and there. We'll talk a little bit about maintenance. My big gripe over the years has always been that we always seem to have time to fix stuff, but we don't always have time to prevent stuff from needing to be fixed to begin with. And now Mike's kind of growling a little bit in the back of his mind over there, because see, he makes his living fixing stuff. So there's a lot to be said for both, but you guys do preventative maintenance too, don't you, Mike?
We only do for a couple of customers in the area. We try real hard to stay out of the routine engineering business, because that's a young man's game, and I'm not really fond of that anymore. But yeah, and even so, it's important to me to spend people's engineering dollars, scarce as they are, on making their facility better. It frustrates me to no end to come in and have to fix something that worked just fine before yesterday's storm. That just grates on me. That's not good engineering.
Right. Well, and especially in a lot of cases, sometimes the solution, although they can be difficult to find on occasion, sometimes the solution can be a really simple fix.
Like the 680 problem.
Right. And we'll talk about that a little bit in a couple of minutes. And so, yeah, it's spending a little to save a lot. We're also going to go outside the building, because we are focusing primarily on AM sites this week. So there are some things unique to AM that we don't deal with FM, TV, or anything else. And that's where Mike's strength really shines through, because he's an AM guy. He deals with that ancient modulation. Or is that antique modulation, Mike?
Well, I'm an ancient guy dealing with antique modulation, so
there you go. All right, now a few housekeeping things before we get rolling. You do have a control interface, a little window on your screen. At the bottom, there's a section called questions. You can type in questions. At the end, we will try to answer any questions that have been put in. If we do run out of time, and Mike, I know you've got to dust out a little early because you've got an SBE meeting with hurricane preparedness as the topic, if I'm not mistaken.
That's right. So I'll need to bug out about 40 after the hour, but I've got you've got me till then.
All right, very good. So any questions that are directed to Mike, because he'll be pretty much gone by question period, just type them in anyway. We'll make sure he gets them so he can send them back to you. Anything we don't have time to do will absolutely will be followed up with email later on. So feel free to answer the questions. If you don't see a little control panel, you've just got a little bar of icons there. The orange arrow at the top does open the control panel. All right, with that in mind and that said, let's go. So the first thing we want to talk about is grounding. And anybody who's seen any of our grounding presentations or written any of the articles in the tips and tricks that I write on occasion, you'll know we're always talking about single point grounding. We're not going to stop lightning, but we can, to some degree at least, control where it goes. And it's a voltage divider theory. So we're going to discuss that a little bit. Going to talk about the importance of bonding grounding connections as opposed to just folding two straps of copper over each other and hammering them flat. We'll talk about surge protection and the best way to install one. And it wouldn't be a presentation by Jeff if it didn't have ferrites mentioned at least 4 times. So we'll talk about ferrites and how to track down ground loops, things like that. So that's the basic things we want to look at with grounding. The big thing with grounding, and you'll notice in this picture on your screen, we're showing a bulkhead ground for a bunch of coaxes leaving. And there's a few things wrong. Number one, they're bolt-on connections, which with a bulkhead panel, you don't have a lot of choice about. But number two, those straps are run around and looped, and they could be made quite a bit shorter if they were just running down straight and coming in from the top of the panel rather than going to the bottom like they are. So always think in the terms of short, straight runs whenever you possibly can for grounding. Have them connected to the station reference ground. And by all means, use proper grounding kits. Mike, you and I have both run into this a lot of times where you'll run into something where somebody's got a piece of copper braid hose clamped to the shield of a coax or something like that.
Yes, and I respect the fact that in an emergency that might not be a bad fix for a weekend, or uh-oh, I don't have a ground kit, what do I do now? But the old joke is there's nothing as permanent as a temporary installation. And it's like, no, guys, go back and fix it. Do it right. Put it on your list, come back, fix it right. That's my philosophy.
Exactly. And I mean, there have been a lot of times over the years where you'll come in and, I mean, everybody's seen pictures of like an AM antenna with a pair of vice grips holding the feed line onto it. And, you know, radio station temporary, 20 years later, those vice grips are still there and sometimes even covered with a couple of coats of tower paint.
Or enough rust to where they just finally fall apart one day.
Exactly, exactly. So definitely keep the ground short, keep them straight. We like to see them bonded, preferably soldered. Well, I like CAD welding. I mean, where else do you make something go boom on purpose? You know, I mean, put a ceramic mold around your ground rod and the cable going to it and touch it off and it goes boom, and now you've got a permanently exothermic connection.
The problem with CAD welds that I see is that you have to have a different mold for every different type of connection.
Right.
And so unless you're willing to invest $400 or $500 in molds, you know, whatever you've got is going to be not the one you need.
And that's true enough. So in that case, brazing is certainly an option, and that's what we're looking at here. This is a station owner and his contract engineer, and the owner's the one doing the brazing. And you'll notice from the flash that it's not being done during the daytime. They had a compression connection, just they've got a 2-gauge ground wire coming out of the building through one of those screw down compression connections onto the ground rod. And I happened to be walking down and he was so proud. It was an excellent system. He had it well grounded and well laid out. But I grabbed the ground cable and stood up with it in my hand. It had been in place less than 4 months and the copper had compressed enough within the connection to get loose enough that it wasn't making a connection at all. So by all means, exothermic connections. I prefer brazing or CAD welding, soldering, silver soldering. There's pluses and minuses. Plus, it's much more convenient and it does give you a decent connection. Over the long term, I'm not sure how viable it is as a long-term connection. Mike, do you have input on that?
I try to avoid clamped connections whenever possible. My experience has been like yours, that the copper, I don't know the mechanism behind it, but it settles or it compresses or It's a thermal issue, cycling, I don't know, but you come back 6 months or a year or two later and it's loose or looser than it should be. So the only time I ever sign off on a clamped connection is when there's some good reason not to weld it. Like if you welded it on the leg of the tower, it would collapse. Other than that,
Right.
always do a proactively brazed, soldered, CAD welded, some sort of metal to metal, the metal actually flows connection.
Yeah, and what happens with copper? Copper's malleable. It's a soft metal, so as it is compressed, it attempts to flow to displace the air within the connection. And especially with stranded wire, you're never going to displace all of the air unless you're using a $1,000 crimp tool or $500 crimp tool, depending where you buy it. So copper connections with like any kind of compression connection will tend to get loose. By the same token, a lot of times you'll walk into a site and you'll see two pieces of strap joined together by folding them over a couple of times, hammering them flat, driving a screw through them into the floor. And the issue there becomes that the surface of the copper oxidizes because, again, you did not displace all the air. You can't. And unless you've got it coated with no-ox, which can help, over time it becomes less effective because it becomes resistive.
Yeah, the only good thing about joining copper straps inside a building is that generally you can use a soft solder, or at least a high temp version of soft solder there, because the heat involved in 15% silver solder is rather extreme. You have to be very careful what else you heat up while you heat up the copper.
Right. I mean, doing the grounding and burning the building down obviously isn't the best alternative.
That's what Mr. Spock would call an undesirable outcome.
Exactly. So the other thing to make sure of, and Mike and I did a quick run through and he saw this, and I'm surprised he's not giggling in the background now. Maybe he had to mute his mic just to make sure. But make sure your ground
a few times.
really make sure your ground really is a ground. In this case, the station owner did the install, did the grounding, saved some money on a contract engineer, and an engineering friend of his had told him that he could ground it to any cold water pipe. Cold water pipe, maybe he should have specified a metal cold water pipe.
He said any. What part of any isn't clear?
Right. Now, and this comes back to, this is an extreme example, but the site that Mike and I were discussing earlier in Memphis where we first met, the reason I was there was because they'd been having a lot of PA failures on one of our transmitters. And we went through that site from one end to the other. Oh, there were what, 2 or 3 trips there, Mike? Something like that?
2 or 3 trips on your part, and of course we were camped out there for months. We rebuilt the entire site, put the transmitter in, rebuilt the 5-tower DA, proofed it, tuned it, did the ATU's new controls, everything. And nobody had any clue. And whatever we did, it kept blowing up and kept blowing up and kept blowing up, and it was very frustrating. And you finally solved it.
Yeah, and what ended up happening, we started out with the obvious stuff. We looked at the tower, we tightened up the ball gaps, we added some polished carbon ball gaps inside the ATUs, checked all the grounding. What it ended up being, and I'm afraid I can't take credit for it, Wendell Lonergan, who's now our head of sales, but was our one of our engineering guys at the time on a site visit, happened to check the grounding lead coming down from the transformers from the pole pigs outside the building, and discovered that that ground cable ended 6 inches below the grass, that it just went into the earth and was not actually connected to a ground rod. So one strategically located ground rod and a little bit of strap to connect it over to the building, and that problem, or that site, I think, had been fairly trouble-free since then.
I believe you're right. Another unique thing about that site, you don't see it much anymore, but you did see it every now and then back in the day. That is that was a corner grounded 480. I want to say it may have been 240, but it was a corner ground instead of the standard Delta or Y. A corner grounded Delta. Yeah.
Yeah, and we do run into both on occasion. I mean, we see all kinds of AC configurations. The only one I don't like to see is open Delta.
Oh, that's poison. Absolute poison.
If you do have a 2-transformer open Delta, then you're better off configuring the transmitter to run single phase and running it across one leg.
Yep. Run, do not walk for the exits. If you see two towers, only 2 pole pigs on the tower, on the pole.
Right. Well, these days you can configure anything for single phase pretty much. I mean, for AM, once you get above 5 kilowatts, it gets a little more challenging. I guess there are some 10 kilowatt single phase, but at the high power levels, especially, yeah, 2 transformers with the lack of regulation is just a frightening thing. Most power companies will do something to convert a 2 transformer to a 3 transformer because it's an issue for them. Some not so much. So it's always good to work with your power company on stuff like that.
Yeah, down here in swamp country, we have sites that are very, very isolated. And a lot of times the power company has really balked on providing a closed delta or a Y3 phase, because that means they have to run a third hot, sometimes for miles and miles. I've had them want to charge as much as $120,000 to upgrade from an open delta to a closed delta at an isolated transmitter site.
Right, and in a case like that, it's almost an argument to run a phase converter and run single phase in.
And then that's what we did, in fact, at a particular site out in the Atchafalaya Basin.
Right. Talking about the AC lines coming in, definitely you need a surge protector. And I'll tell people flat out, I don't care whether it's one of ours, a polyphaser, Transtector, LEA, Control Concepts. There are thousands of them out there. We mostly use one outsourced from Raycom now. And the surge protector, MOV, gallium arsenide, don't care. It's a must. You got to have one. The funny thing is, and we'll talk about this again next week in the FM session, but MOVs are a bidirectional device. So if your tower takes a strike and ground potential spikes up, it can decouple out to the AC lines. If you do get an AC surge, which at the end of a long run in a rural area you can, then it can decouple it to ground. So the big thing about surge protectors is location, 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 just like real estate, just like transmitter facilities. You want to keep it as close as you can to the main electrical entrance, because the highest inductance, therefore the highest impedance to a lightning strike, will be the short diameter, small diameter, relatively small diameter wires to the surge box. So having your surge box way over by your reference ground isn't nearly as good as having it up by the AC lines, where the AC comes in. And one other thing, and you'll see that on this picture, don't run the ground. And number one, your surge protector needs to have a ground connection. Number two, don't run that ground through a conduit. Conduit's ferrous material. It's just like putting a giant ferrite over a piece of wire and creating a choke. So you've just added impedance to your lightning path. And this is the path we want the lightning energy to go, not one where we're trying to prevent it.
So would you leave it open the whole way, or is it okay to have a stub like you have there, as long as it's not connected at both ends like a shield?
For the conduit, I would prefer to have a non-metallic conduit, or to have the ground wire actually physically bonded to the conduit. Make the conduit part of the ground wire.
Okay. Huh.
Depending on where you are, what building you're in, what city you're in, different codes will require different things. Sometimes you don't have the option. Sometimes you have to run. And this particular surge box is in Hancock in Chicago, and steel conduit's a requirement. But
I second what you said about impedance with the surge protector. That when the surge protector fires, it's a very low impedance short, which is what you want it to be. But you have to really seriously think about the impedances of both the hot and the ground wires. Think about from where the actual surge hits and goes past the surge protector, or if you don't do it right, to affect your transmitter. You want to make the impedance, which is more than just the DC resistance. It's actually the impedance of the steep wavefront to the surge of the surge. You want to make the impedance to ground, and I mean ground defined as the common ground for the whole site, as low as possible at that point. And that's important.
Now, I've got to chuckle a little here because I was teasing Mike earlier. He was griping that he didn't have any good pictures of himself, and I was teasing him earlier that I had one of him napping during one of my lightning protection sessions in Louisiana, but I think he must have been listening.
Well, that's because I had probably heard all that at least 4 or 5 times before that.
More than once. So definitely the AC wiring is going to be typically the choke point. Most surge protectors won't take an AC wire above about a 6 gauge. So you've got a fairly high inductance per foot, and keeping it as short as possible is definitely to your benefit.
Now there are high-end surge protectors that are called series devices that you actually pass the entire 3-phase or single phase through, and they are arguably the most effective if you provide them with a good ground, because literally everything has to go past them to get anywhere else. But
Right.
those, you're talking about bucks for one of those.
You're getting into the thousands of dollars. The way they work typically is with a series choke in the line, and then MOVs ahead of and on the load side of the choke as well. The disadvantage to them is if you have to do any maintenance on one, you've got to shut down that whole line, which means taking your station off air, whereas a shunt type device can be put on its own breaker and shut down for maintenance without taking the transmitter down.
Right, and if a series device has a serious failure, you are dead in the water until you wire around it.
Exactly. So definitely there's pluses and minuses to both. The series ones give much better protection, but it's a cost benefit analysis versus, you know, what's it cost me to be off air while I'm doing maintenance on it. And like anything else the current flows through, eventually current will stop flowing through it. Now, my next big thing, and I forget where I was, but not too long ago, somebody suggested I probably should get a picture of a ferrite tattooed around my wrist. It's the one thing that I really like to beat the drum on. Ferrite toroids are cheap, they're easy to obtain, and they're easy to install. And anything that has a feed and a return path through it, where you've got current going out and current coming back, preferably equal values, should have a ferrite on it, especially in a transmission facility, but you can use them almost anywhere. They work well on coax, more so than anything, except maybe AC cables. You can put them on audio lines, you can put them on phone lines, you can put them on cable modem connections. They are not on their own going to solve all the problems of the world. But in conjunction with good grounding and good surge protection, a ferrite can be the difference between having failures and not having failures. Remember that what we're dealing with primarily as we come back from the antenna to the AC lines is lightning protection, is a voltage divider theory. We look for all the places that lightning can go, make the path through the surge protector between the ground and the AC lines the lowest impedance path, and raise the impedance of everything else wherever we can. Adding ferrites is one way to do that.
Also, ferrites can be a useful troubleshooting tool. If you have a ferrite that's getting hot, you've got net current going through it. So yes. We had a situation a few months ago in Mississippi where we had a ferrite on the output cable of a 5 kilowatt AM transmitter, and it got hotter than a firecracker. And what we found was that at the ATU end, the outer conductor of the coax had opened up, and the connection was still being made through the grounding system, but no longer through the actual outer conductor of the coax. And once we fixed that, then the ferrite went back to being cool. So that was a useful diagnostic tool.
It's an excellent tool for that. I'll give another example. I did a station in San Antonio many years ago, and they had installed ground. They had ground everywhere. There was ground going from the transmitter to the phaser to the backup transmitter, out to the earth connection, over to the surge box. Everything went everywhere. There was hundreds of feet of copper in this room. And when we put the ferrites on and turned the main transmitter on, the new transmitter, the ferrite on the coax for the standby transmitter got too hot to touch. So we knew we had currents flowing everywhere. And what we ended up doing was pulling out close to 3/4 of the grounds, running each piece of equipment back to a single reference point. And yeah, like you say, it dropped right directly to ambient temperature. So they're great also for common mode signals, induced RF. If you've got an AM and an FM co-located and the AM audio likes to get onto the FM exciter, And this would be more for older equipment. Some of the direct-to-channel stuff, you don't see that, although it can still be an issue, especially with FM translators on AMs now. Then a ferrite on the audio cables will sometimes do a really good job at getting rid of any induced RF. They also help for power line and power supply noise. I can't think of an example of that right now, but Mike, how about you?
Well, we routinely install them on any audio and remote control to a transmitter. We had a site long ago here in Louisiana where they decided to move the studios back to the transmitter site to save money in the building, and they've got it's just a little 1 kilowatt AM, but the shunt fed tower is about 10 feet behind the back of the building, and so they've got relatively modern studios in there, and there was RF on everything, literally everything, the phones, the computers, the audio, the mics, everything. And we ran around with a bunch of little ferrites and wound 2 or 3 turns to each ferrite, and that got rid of about 90% of the RF right there without doing anything else.
Yeah, so I mean, definitely they're a great tool for things like getting rid of induced noise. By the same token, they work just as well on lightning surges, where your surge will tend to be either on the center conductor if you get a tower height strike that, for whatever reason, doesn't go through your ball gaps, or if you happen to have a ground spike where a grounded tower, like if you've got a folded unipole and it got hit, then ground potential is going to spike high. What the ferrite will do when you get current flowing through one side that's unequal or imbalanced to the current on the other side, the ferrite will saturate and attempt to induce an equivalent signal on the opposite connector. So as long as the net difference between the two stays the same, the risk to the equipment's a whole lot less. All right, on to the next. And this comes back to ground loops. And so many times you'll run into a site, and of course, a lot of radio sites have been around for years, and things get added, and things get added, and things get added. But a lot of times they just get added on top of the old stuff, and you'll end up with wires going everywhere and strap going everywhere, and you don't really have a lot of control over what's going where. You end up with ground loops, you end up with hum. I'm sure almost everybody listening has got at least one story of going into a rack full of quad foam cable and finding one that had 120 volts AC on it. Things like that. So clean up the old stuff as you put the new stuff in. I mean, it's a simple housekeeping thing. It does add time to the project, but it'll save you or the next guy a whole lot of grief down the road. And
well, this is important at transmitter sites, and of course, very much so at studio sites. And you and I have both seen too many facilities where whoever came in just layered the new stuff in on top of the old stuff and left all the old stuff laying there, sometimes even connected to stuff. And it's like, no, take 5 minutes extra and clean it up. Because how many times it's like putting a new roof over the old roof. Okay, it works once. What are you gonna do the next time? Put a third roof on? No, you clean the old stuff up every time you put a new layer in.
Well, and one example would be I was in it was a co-located site. It was down in Georgia, I think, and we were doing some work on the transmitter, and they had a bunch of wiring, and their guy was cleaning up some wiring at the same time, and he came across a rack with a bunch of stuff in it that he'd been told never been used before. He started disconnecting stuff, and the transmitter went down. And what it had turned out was they had the interlock off the transmitter, was going into that rack, had gone to an old console that had been removed, so the DJ or whatever could interlock the transmitter manually from the console. Don't want to know why, don't care. And in the rack, when they disconnected the old console, somebody had just taken the other end of that piece of wire that had gone to the console, pulled it back into the rack, twisted the ends together to close the interlock permanently. Well, as soon as he started to disconnect it, open the interlock, transmitter's off. So by all means, cleaning up the old stuff can save you a lot of grief down the road. What we run into with the typical site, you have the power pole out by the road, you have the antenna out in the back in the field, and you have the transmitter sitting in the middle for the lightning current to go through. This is fairly typical, and the goal really is to try to convert that to something like this. And this is where I say the Ferrites in conjunction rather, with a well-installed surge protector and good single point ground system go a long ways toward helping basically remove the transmitter from the equation or make it a much higher impedance to lightning energy. So that's our goal, and that's the situation that Mike and I ran into because the power company ground wasn't physically connected. And this is something that a lot of folks will, you'll run into a lot of electrical inspectors even now, and it varies state to state as to what version of NEC the state follows, if they follow one at all. Mississippi, for example, does not recognize any specific code of NEC or version. Louisiana, I think you guys are on the 2014 code. Alabama's on 2017, so it does vary state to state. But as of 2011, Article 250 of NEC was rewritten to specifically require that electrical ground and facility ground must be connected together, bonded. And that is an argument you can always make if you get an inspector that doesn't want to see that happen, or a power company guy that resists having the power company ground connected to the facility ground.
Yeah, I've had to fight that more than once with a code inspector, and sometimes the easiest thing to do is just to do it their way and wait till they're gone and then do it the right way.
Had that conversation more than once as well. All right, so rolling forward, one of the other things, this is, and I know Mike, you and I were talking about it earlier, this is one of the biggest, I guess, questions or things. It's my new shiny toy. This is the thing that I like more than anything else in my toolbox right now, is the little FLIR 1 voltage meter, or sorry, infrared camera. It just attaches right onto my Android phone and lets me take a thermal imaged picture of the, well, I use it every time I walk into a site and take a picture of the breaker boxes. And you can see a hot breaker without even opening the panel. So by all means, those are incredibly useful tools. They're a couple of $100, but I think they're probably worth every penny of it. I think Caterpillar makes a Android phone now that has got thermal imaging built into it. And of course, there's several other brands out there. Mike, have you guys got any of those?
We do not yet, but I've been tempted to buy one. One of my associates has bought one and seems to be fairly happy with it. And I know that Stan Carter, the EMF engineer in this area, bought one recently and has had a great time running around transfer sites finding heat problems that no one knew existed. So it's on my list of toys for 2018 for sure.
Good, good. Yeah, no, they're an excellent tool. And one of the things you'll find, and this comes back to compression connections, because of course copper is a malleable substance, and breaker terminals are always compression connections. And that's the one place that you're going to see things work loose faster than anywhere else. So, I mean, right after I got this, I took it down to the basement, took a picture of my breaker panel at home, and found out I had a couple of loose connections. So saved me some grief there. All right, clicking ahead. So in the don't try this at home category, one of my customers knew I was coming and said, yeah, we put the Ferrites on and grounded the surge protector, and sent me some pictures. So I had to give Rod good credit. Rod, I don't know if you're attending, but if you're not, we're making fun of you right now. Anyway, by all means, I wanted to put these pictures up just, I say, I know they're a joke, but we do see a lot of, like what Mike called earlier, a temporary solution is the best way to ensure permanence. I paraphrased, but that was basically it. Radio station temporary is a thing. And it's okay to get you through this situation, but it really does need to be addressed and fixed whenever it can be, because it will cause somebody grief somewhere down the road. All right, now getting on to maintenance. Wow, we're getting tight on time, but we're doing okay. There's some few things that really need to be covered in maintenance. Air filters are one of the big things, and air conditioning system maintenance, cleaning out condenser coils, just exercising air conditioning. If you've got a lead lag system, swapping them back and forth so you get the same run time on each. The one thing I don't see here that I really should have is generator testing. Generators need to be exercised on a regular basis because, like a backup transmitter, there's nothing worse than a backup system that doesn't work when you need it. I mean, I don't remember who said it, but somebody told me once that backup transmitters and generator systems need to have higher reliability than the mains because they're the one thing that has to work when you need it. So, you know, I'll go ahead, Mike. I hear you breathing.
Well, and no backup system that isn't tested on the regular can be counted on in an emergency. If you don't test your backups, count on them not working when you need them.
That's exactly right. I mean, it's definitely a roll of the dice. And by the same token, anything that isn't running full time, and I mean, this would include an AM daytime station as well, where you're off air overnight. You're subjecting all the hardware to heating and cooling cycles, which can cause things to work loose. So on a fairly regular basis, at least once a year, I recommend, you should go through the ATUs, tighten the filter capacitor connections, or make sure they're stayed snug. Go through the power supplies, especially big iron supplies, the transformer supplies, and rectifier hardware, and make sure all the connections to that stuff are snug. In the air handling system, check the belts and blowers on a fairly regular basis. Even in the, whether it's cooling the room or whether it's a squirrel cage blower for a tube transmitter. I mean, those are regular maintenance items that do need to be checked. In that mythical perfect world, every now and again, you'll check the ground system just to make sure it's still there. And I mean, that sounds funny to say, but more and more these days, there are a lot of situations where it won't be there. And just general cleanup, housekeeping stuff. I mean, there's nothing more frightening than walking into a site with half a dozen pieces of loose Schedule 90 conduit laying on the floor. And I mean, just trip and fall hazards, dangerous stuff like that.
Well, and let me say one thing about backup generators in particular is that if you don't go out and actually simulate an honest-to-God utility failure, you have no idea what's going to happen when that occurs.
Exactly.
Just relying on the generator's weekly exerciser to say, oh, I checked the box, it works. No, you didn't. Go out there at a time of your choosing when it won't be a disaster if things don't go right, pull the main breaker and just watch and see what happens. And I'll bet you dollars to donuts that half the sites aren't going to come back upright. You're going to have problems you're going to have to address. And it's a lot better to address it on your schedule when the dog's not barking, your kids aren't sick, and the station is off the air at a time when it's not a disaster than when it occurs at 4 o'clock on a Friday afternoon with the big high school football game going to start in an hour and a half.
Exactly. So the thing about air filters too, change them on a schedule. We can't tell you when they need to be changed. That will purely be determined by your site. A well air conditioned site, you might find you go years between air filter changes. Forced air in the middle of a cornfield or down in the bayou somewhere, you might find you go days between changes. So it will vary a lot from one site to another. If you do have gear with metal mesh filters, they usually can be washed, but make sure they're dry because nothing worse than blowing air or water through your transmitter. Water cooling only works when in a controlled circumstance and not so much with an air flown system. And most metal filters require some sticky coating like filter coat or something like that to be squirted on them to make them fully effective.
I wouldn't even use the words fully effective and metal mesh air filters in the same paragraph, but that's the same sentence.
But metal mesh filters work fine when they've got the filter coat on them. They're not nearly as good as like a pleated paper like what we've got in this picture here. So, you know, different applications, different requirements. And again, beating the drum on compression connections, absolutely make sure they're tight. That I don't know how long ago that picture was taken, but more than 5 or 10 years ago for sure. I see I'm working on an ND10 power module, but again, just tightening the terminal block connections on the bottom of a power amplifier. So any kind of connection, once a year, like I said, go through, check power supplies, circuit breaker connections, any kind of filter connections, grounds, everything. I mean, all that stuff should be tightened on a schedule. And like I said before, make sure your ground is still there. It's a really good idea to pull the unused cable off the tower instead of just cutting it so it's not causing a parasitic signal flow of some sort. And I mean, it reduces tower load. Now, in some cases, some of the situations I've seen, the coax may be the thing keeping the tower up because it adds rigidity. I don't know. But it's a good idea to pull that stuff whenever you possibly can. And here's another one from Mike's backyard. This is taken down outside of New Orleans, but go through with a shop vac now and again. And I told somebody not long ago that one thing I like to do with the shop vac in a transmitter, especially these days with all the semiconductors in there, is to take a piece of zip cord, strip about 6 inches off one end, and just hose clamp it to the end of the shop vac hose, and then connect the other end to the equipment chassis, so that you don't build up static while you're working with your shop vac.
That's not a problem we ever run into down here because the humidity never gets that low.
Yeah, well, it does require humidity to be somewhat less than 105%. That's true. But in drier areas, it's an issue.
I find that an effective combination is an air compressor with a blowgun attachment and a vacuum cleaner and a brush. Because you can knock off the dirt with the brush, and then you can blow it out of the way with the air compressor, and then you can suck it up with the vacuum.
Yeah, I tend to leave the compressor out just because I don't like to locate the dirt from a place where it wasn't arcing to a place where it might. But as long as you got the vacuum involved to get the dust out of there, then you should be fine.
Well, the compressor can be used to move the dust to a place where you can vacuum it up with the vacuum cleaner.
Exactly. All right. So moving forward, by all means, and Mike and I made the comment when we were doing our pre-run through this, that this wasn't the worst that either one of us had ever seen. But just basic cleanup, addressing fencing. I've walked into sites. I walked into a site not long ago where the gate was in perfect condition, but there was no fence at all. And this was around a hot 50 kilowatt AM tower. So these sort of things, you do need to visit the site now and again and just make sure that stuff is being addressed. Spark gaps are another thing that maintenance is sometimes overlooked on. Metal gaps, especially every time they arc, you'll get some metal migration, so they do require rework, or in the case of tungsten balls, you may need to turn them on the rods. I like polished carbon balls because they don't suffer from metal migration, but on the other hand, in a severe strike, a polished carbon ball can vaporize. It'll just explode and disintegrate. So definitely those are a situation. We do have a way to calculate balls. This is an Excel spreadsheet. If anybody wants to get in touch with me after the fact, I can certainly send you a copy of this. It's a spreadsheet that actually, the guy who is now our head of test room wrote probably 20 years ago almost. But for any specific ball diameter and load resistance, we can tell you pretty closely exactly where that ball should be set. Okay, I see Dave Reitner popping up in questions already saying he wants one. Hey Dave, how you doing anyway? And it's a one-way street, don't talk back. The other thing, and Mike and I had this conversation earlier, NRSC, Mike says that he doesn't, well, I'll let you express your opinion on it, Mike, but NRSC is something that is a requirement in the US. So like it or not, it's there.
It is, and we do NRSC measurements for a number of stations and have for years and years. But I have to tell you that, in my opinion, I'm going to avoid the use of the term waste, but it's of marginal utility to most radio stations. That of the hundreds and hundreds of tests I've done, there were a handful of cases where I found something that was almost incidental to the test. I found frequency had drifted, And of course, technically, a frequency measurement is not part of the NRSC. We just do it because our analyzer has that capability. Or every now and then in the early days, we found that the audio processor had not been properly rewired or modified, and the 10 kilohertz notch filter, low pass filter, wasn't actually in the circuit. Things of that nature. The number of times we've actually found a transmitter that, quote, would not pass NRSC, unquote, was maybe 2 or 3 out of 400 or 500.
Right.
So,
Now, one thing where you will find it as we go along, and I've heard cases of it, if nobody has complained about to the station already, is when you start getting spurs showing up on PDM frequencies for a PDM transmitter, where the filter caps start to go a little soft.
yes, and
I
we're
know,
seeing that more now because our PDM transmitters are getting elderly.
right.
Yeah, we do see that every now and then. And part of the problem with that, of course, is that it's difficult to convince a radio station owner to spend his scarce engineering dollars on fixing that unless they're actually interfering with somebody else.
Right, exactly. So it is definitely something that you can see with an NRSC measurement, even if somebody hasn't complained. But typically, unless there is a complaint, sometimes getting the ownership to pony up to spend a couple $1,000s on stuff like that can be a challenge.
Well, and I've had this confirmed to me both by the local, the New Orleans FCC field office, and by various engineers around the country, that the FCC at this point is essentially in complaint response mode. That unless they receive a complaint about a station, they're basically not going to go out and check station operation like they did in the old days. So.
Right. Now, my theory and general principle, I'd rather see things kept as well as I could possibly have them. That way, if there ever is a complaint, I've got all my ducks in a row. That whole willful and repeated phrase is also something to pay attention to. But on that topic, one of the tests that you can do that is of some value is monitor points. These days with method of moments or moment of methods, which is it, Mike?
Well, you can say it either way, method of moments or moment method. Same
Okay,
thing.
there you go. A lot of people don't run proofs and radials the way they used to. It can mostly be done theoretically, and that's fine, but knowing what your coverage area is a useful thing, and it can be one of the fastest ways to let you know if your ground system's starting to erode.
Yes, I'll second that. And I won't give you particulars, but there are a number of stations that over the years, the monitor points have all slowly gone down, and that's generally attributed to decaying ground systems. And I have seen situations where it came back and put in a new ground system, and the fields all definitely came back up, sometimes to the point where it was a problem. But yes, monitor points, or even making some measurements for test purposes, if you make enough of them to make them statistically useful with an analysis software, will certainly tell you whether you're or can tell you whether you're putting out the actual field that you're licensed for.
Right, exactly. Now, we do have sources for information online. Definitely our newsletter, webinars such as this one. This will be archived within the next few days. If you go to the webinars tab, you can access any other one we've done over the years, and there have been a lot of them. We do have a YouTube channel. If you go to the support pages of our website, customer service has been starting to do some how-to videos here and there too on setting various things up. Mike, I know we're getting near the time you had to dust out. Actually, I think you're probably running 5 minutes late already.
I am, but I'm just trying to hang in as long as I can.
Well, we've hit the primary content point. Question-wise, I think I can whoops, there I go, clicking too fast. Sorry, people. Question-wise, there's nothing here that I don't think I can deal with. So it was a pleasure to have you, and thank you very much for taking the time out of your day. I know you guys have busier than one-legged paper hangers recently, and really glad to have you along.
Well, thank you. It is a crazy day today, and I'm going to hang up here and run to my next obligation. And thank you very much for having me. I hope I contributed, and I tried very hard not to fall asleep this time.
All right, Mike, we'll talk to you in a couple of weeks. I'll be down in New Orleans.
I look forward to seeing you, my friend. Take care.
All right, so folks, definitely we do have resources. There are a couple of questions here I want to take a moment to get to. Laverne Siemens from Golden West Media out in Western Canada, well, almost Central Canada, but who's counting, had mentioned putting a transmitter on one of their sites, dry, windy spring, and a number of static pops on air and power cutbacks, appearing to be static arcs across the guy wire insulators that they didn't notice with the old tube transmitter. And I know that Ed had said that he sent Laverne a response telling him he was going to send it to support, but this is a question that I can deal with, so we'll handle it. The short answer is that's correct. It is going to happen. It does happen. The solid state transmitters tend to have much faster shutback circuitry. So they tend to cut back really quickly on arcs across guy wire insulators. About the only options, some people have used static dissipators like static cats, things like that, point discharge, intentional corona, I call it. That will help in some cases, especially with stuff like this. Where we get it here in the coastal area, surprisingly, we can get snow with really low humidity, and it will cause the same situation. Other things that help is beefing up the static drains to give you a better DC path to ground as things start to ionize prior to arcing over. But again, that's not going to be the do-all end-all on a dry, windy day. If your guy wire insulators are arcing a lot, the other thing to be concerned about is that eventually they'll start to build carbon trails across them, and then they're not insulators anymore, they're conductors waiting to happen. So that should over the long haul be addressed, but I do understand that replacing insulators is not a trivial task by any stretch. So so definitely it can be a situation. There are some things that can help mitigate it. Probably the point discharge stuff is one of the better things I've seen as far as that, although there's arguments both for and against them. Anywhere I've seen them go in, they've been useful. Let's see. Can poor grounding contribute or cause harmonics? Not so much, Mr. Navarro. Where poor grounding tends to be a bigger issue is with lightning protection, obviously. Harmonics primarily are a function of the amplifier type used and the filtering after it, or in some cases, there could be intermodulation products with other signals in the area. But grounding typically won't contribute to that a whole lot. What else do we have? Three-phase isolation transformers. Oh, Ed Delaney. Hi, Ed. Three-phase isolation transformers on an open delta with decent success. That's a good idea, Ed, because that way you can effectively convert your unbalanced three-phase to a grounded. And again, it would require a good ground reference, but that's a really good idea. Thanks. Leandro Clado says about ferrites, any special considerations for use in audio or RF in terms of specifications? In other words, are some better for audio and others better for RF depending on frequency? And Leandro, the answer is yes. For lightning protection, not so much, because we're doing common mode protection. We want the highest iron content we can get in the ferrite. So like a J material or a 43, depending on the version of ferrite you're using, but something with a fairly high iron content. If you're using it for filtering, like making a series choke, then definitely ferrites do have a specific cutoff frequency depending on their composition, and you'd want to pick one that was appropriate for that one. But absolutely, that the ferrites for lightning protection, we want the highest iron content we can get. Justin Halenga makes a comment that one of the engineers loves to not take care of spider webs to kill the bugs, and that's actually not a bad idea. Although I'd argue that I'd keep the spider webs out of the transmitter, because otherwise you've potentially got the world's most expensive bug zapper going on. But yeah, no, I mean, if it works, it works. I like to see things a little cleaner, and if I ever walk through a web on one of those sites, you'll see dance moves you've never heard of before. But definitely, different people have different ways of maintaining things. Howard mentions, let's see, we've got about 4 minutes left. Howard mentions rely on ground rod only for code compliance. In South Alabama, ground conductivity is only 1 or 0.5. Earth ground is the same as glass. That is true. And absolutely, that can be a case. I mean, in some situations, you can make a difference if you drill a well, for example, but it's a really high cost. If you have multiple grounds and have them tied together with strap properly bonded, you can create an effective ground, and for mountain sites, that's sometimes the situation. So definitely, that's something else to consider. Let's see, taking a look down here. Okay, any suggestions for a more effective filter for our shiny new NX50 in a very dusty location? The NX50 comes with a MERV 8 pleated paper filter, if I'm not mistaken. That's and I'm going off the top of my head here, so I could be wrong. That's what we tend to use the most. And the challenge is if you put in a tighter filter, and I had this conversation in a Facebook post actually, I think it might have been this morning or yesterday, but if you try to go to like a MERV 11, you reduce the airflow through the transmitter because it's a more dense, less pores per inch type filter. So it's a really tight, it's a tightrope you're walking there. You definitely want to pay attention to the airflow as well as the filtration capacity. One suggestion would be installing a clean air room so that you bring all the air into the building through a wall of fairly coarse filters with forced air, and then use something like much higher density bag filters to bring the air out of that room into the transmitter room. You could build a room, 8x8 room out of plywood and throw a couple of blowers in it and then a wall of filters on each side. It might be a cost-effective way to get you better filtration if you've got to rely on forced air. Okay, we are running out of time, folks. I want to thank you very, very much for coming by. There are 1 or 2 other questions and comments that I will have to deal with email, but I certainly will take care of that either today or tomorrow. Thank you very much for joining us, and hope to see you again soon. Have a great day.